Draw the following fractions: 1/2, 2/4, 3/6, and 4/8. Okay. So let's do it in circles. So what would 1/2 look like? 1/2 would be, we're just trying to find out how to make this a perfect semicircle. So that means this would be 1/2 and this would be 1/2. So what is 2/4? That means we need to have 4 parts of the whole, right? So how do we make 4 parts out of this? We can continue to find a half. We can find a half, and then we can find the half of the half. So in this case, let me just mark this in green. 1/2 would be this portion. 2/4 would be 1/4, 1/4, 1/4, 1/4. So I have 1/4. Each of these semicircle, or each of these portions of the circle are 1/4. Okay. And it's saying I need 2/4, right? So what does 2/4 look like? 2/4 is basically just these two guys, right? So it's just this guy. Let me color that in. 3/6. Okay, so let's do 3/6. 3/6 means I need 6 equal parts in this circle. Let me think. How can I make 6 equal parts? Go like that. Make 4 equal parts. And now if I cut it through here, that if I do this, technically this is not correct because this part and this part are going to be larger. So it's not equal. So let's see if I can think of a way to do 6 equal parts. Perhaps I can do... Okay, this means more equal. But of course we have to imagine in our brains that these are all equal. Otherwise these fractions wouldn't make any sense. So we have 6 equal parts, and now we have to label that this would be 1/3 or 1/6. This would be 1/6. This would be 1/6. 1/6, 1/6, 1/6. Now how do I represent 3/6? Well, we just have to color in 3 of these guys. So it looks something like this. And finally we have 4/8. How can I do that? So this way, make it 4, and now I can do that other technique because I can cut this also. Now each of these guys are going to be 1/8. Let me make my pen. 1/8, 1/8, 1/8, 1/8. Okay. And it's saying 4/8. So let's find 4 of these guys and color in it green. So this is 1/2. This is 2/4. This is 3/6, and this is 4/8. And what we can notice here is that, well, what do we see? We see that at all points, at a half, at 2/4, 3/6, and 4/8, they're all covering the same amount of the circle. No matter how many times I cut the circle into equal parts, when I give it these values of 1/2, 2/4, 3/6, or 4/8, we're covering the same amount. And that's really the point of this exercise, is to notice that you can have different numbers represent the same part of the circle, okay? And it's really important that you do notice that, because when I do something like this, or I'll just shrink this, notice what's going to happen when I overlap these guys. So when I overlap everything, so this becomes in here, they're all covering the same part of the circle. It's just cut into a different pieces, okay? And what is the ultimate 1/2? Well, it's gonna be this. It's gonna be this whole portion here. And that is 1/2. Now, what does this mean? This means that 1/2 is equal to 2/4, which is equal to 3/6, which is equal to 4/8. Now, if you're still curious about the relationships between these things, I encourage you to pause here and think about, why is this the case? You have a picture of it, you have everything drawn out for you. What's the relationship between 1/2 and 2/4 and 3/6 and 4/8? Like, can you relate 1/2 to 4/8? Because it's saying here that they're all the same. So what is that? How does that work?